Welcome to the DIY Honda Garage channel. This presentation focuses on Diagnostic Trouble Code, DTC P0122, which refers to a low voltage condition in the throttle position TP sensor A circuit. The TP sensor is crucial for monitoring the position of the throttle plate in the engine, providing vital input to the engine control module, ECM, for optimal engine performance and fuel efficiency. In the Honda Civic models from 2006 to 2011, an incorrect voltage reading can lead to a variety of operational issues, including reduced power, stalling, and increased emissions. It's essential to follow a systematic troubleshooting approach to effectively identify and rectify the technical problems associated with this DTC. In the subsequent slides, we will delve deeper into the components affected by P0122, the possible causes of this error, the symptoms you may observe, and a detailed step-by-step troubleshooting guide to resolve the issue. DTC P0122 indicates a low voltage issue within the throttle position TP sensor A circuit. The TP sensor A is responsible for measuring the angle of the throttle plate, which is a critical component in regulating the engine's air intake and, in turn, its fuel consumption. This sensor is located on the throttle body, typically situated near the intake manifold. It communicates its voltage readings to the engine control module, ECM, which uses this information to adjust various engine parameters for optimal performance. When the voltage is lower than expected, specifically around 0.3 volts or even less, this may trigger the P0122 code and can significantly impact the vehicle's acceleration and overall drivability. Proper diagnostics and connectivity checks between the sensor and the ECM are crucial for ensuring the proper functioning of this system. To understand DTC P0122 effectively, it's important to consider the various possible causes behind it. A faulty TP sensor A is one potential reason, as age or damage can impair its ability to send accurate voltage signals. Poor connections or loose terminals at either the throttle body or the ECM can result in intermittent voltage readings or complete signal loss, which could also trigger this error code. Additionally, any short circuits in the wiring connecting these components could cause abnormally low voltage at the sensor, contributing to the problem. It's also wise to consider that if both DTC P0122 and P0222 appear simultaneously, this could indicate a more complex issue within the throttle system. Identifying the specific cause will help pinpoint the necessary corrective actions to take. The symptoms associated with DTC P0122 can significantly affect the driving experience and vehicle performance. A common symptom is reduced engine power, which can make the vehicle feel sluggish or unresponsive when accelerating. Stalling can also occur, particularly when attempting to accelerate from a stop or during deceleration due to improper air-fuel mixture control. This issue could further lead to an increase in emissions, which is detrimental not only to vehicle performance, but also to environmental health. Drivers may also notice warning lights on the dashboard, indicating a check engine light along with the associated symptoms. Addressing these symptoms promptly by troubleshooting the P0122 code is essential for restoring proper functionality to the vehicle. The first step in troubleshooting DTC P0122 involves turning the ignition switch to the on position, also known as position 2. This is necessary because the vehicle's ignition needs to be active for diagnostic tools to function accurately and collect the necessary data from the vehicle's systems. Once in this position, the onboard systems can be powered up, allowing you to proceed with the diagnostic checks that follow. Make sure you observe all safety precautions before performing this step, as it will enable you to access real-time data from components such as the throttle position sensor. This data is crucial for determining the condition of the sensor and its connectivity to the ECM. After powering on the ignition switch, the next critical step is to clear the DTC using the Honda Diagnostic System, HDS. The HDS is a specialized diagnostic tool used to communicate with the vehicle's electronic control systems. Clearing the DTC is crucial, as it resets any stored error codes in the ECM and eliminates any potential false positives from prior conditions. This step ensures that you are working with a clean slate and allows for accurate data collection in the following diagnostics. Once cleared, you can perform the next steps, focusing on the real-time data without the interference of previous error logs. This step prepares the technician to diagnose the current state of the throttle position circuitry more effectively. The third step in the troubleshooting process is to check the throttle position sensor A data using the HDS. This diagnostic scan will provide you with real-time voltage readings from the sensor, crucial for identifying whether the sensor is functioning correctly. You are looking for a voltage reading of about 0.3 volts or less. If the reading is at or below this threshold, it confirms that the sensor is operating under the expected parameters, thus necessitating further investigation into the system. In contrast, if the voltage exceeds this limit, it may suggest either a malfunctioning sensor or an issue with the wiring connections. Therefore, this step is instrumental in determining whether to proceed with further diagnostics or check for loose connections. The fourth step requires checking for any pending or confirmed DTCs with the HDS. This action helps to see whether DTC P0122 is the only trouble code present, or if there are additional error codes, such as P0222, which may indicate related issues within the throttle position system. If both DTCs appear simultaneously, this is a critical indicator that both sensors may be experiencing issues, or that there may be a more systemic fault in the circuit. Conversely, if only P0122 shows up, you can move to the next steps in the troubleshooting process to isolate the problem further. This step is crucial for diagnosing any broader issues and making informed decisions on necessary repairs. After checking for additional DTCs, the fifth step involves turning the ignition switch to the lock position, or position 0. This step is important because it ensures that all systems are powered down before you begin disconnecting any electronic connectors. Powering off the vehicle mitigates any risk of electric shocks while working with the wiring and connectors at the throttle body and ECM. Properly securing the engine's state minimizes the chances of accidental shorts or system resets that could alter the diagnostic outcomes. Always ensure the vehicle is securely parked and properly prepared before executing this step to begin the physical troubleshooting process safely. In the sixth step, you will disconnect the throttle body's 6P connector to examine its physical condition. The 6P connector is integral as it links the throttle position sensor A to the ECM's circuitry. By disconnecting it, you can inspect for any signs of damage, corrosion, or loose connections that could be contributing to the low voltage condition indicated by the DTC. This physical inspection is vital, as electrical issues often stem from poor contact points or damaged wiring. Once the connector is disengaged, you can further troubleshoot by executing the upcoming tests aimed at isolating the issue in the sensor circuitry. This step is critical for identifying potential problems that could be affecting the sensor's performance. Next in the troubleshooting process is to jump the SCS service check signal line using the Honda Diagnostic System, HDS. This procedure is necessary to facilitate the diagnostic check by bypassing the normal sensor input signals during testing. By jumping the SCS line, you can create a controlled environment in which to evaluate the system, ensuring the fault is accurately identified without interference from other electrical signals. This step allows for more precise diagnostics as it eliminates extraneous variables that could confuse the readings. It is vital to follow the specific protocol for jumping the SCS line as outlined in your service manual to ensure you obtain accurate diagnostics and to avoid any potential harm to the vehicle's electrical systems. The 8th step involves disconnecting the ECM connector C, which consists of 44 pins. This procedure is crucial for inspecting the connections between the ECM and the throttle body. The ECM, or Engine Control Module, plays a significant role as the brain of the vehicle's engine management system, processing inputs from various sensors, including the throttle position sensor, and executing corrections as needed. Disconnecting the ECM enables direct access to its terminals for testing electrical signals and continuity relating to the throttle position circuit. As with previous steps, it is important to handle the connectors with care to avoid bending or damaging the pins, which could complicate further diagnostics. Ensuring a secure connection is essential for reliable vehicle operation. For Step 9, you need to check for continuity between the throttle body 6P connector terminal number 1 and body ground. This is a critical test as it helps identify whether there are any breaks or shorts in the wiring harness connecting the throttle body to the ECM. Throttle body connector terminal number 1 typically carries the TPSA signal, and ensuring it has continuity to ground is essential for proper operation. If continuity is present, it indicates that the wiring is intact, allowing for signal transmission from the sensor to the ECM. In contrast, if continuity is absent, that points to a short in the wiring, which must be repaired before moving on to further diagnostics. This step is vital to isolate the problem in the signal path and ensure accurate readings. The final troubleshooting step involves measuring the voltage between the throttle body 6P, connector terminal number 2, and body ground. This measure is pivotal in determining whether the voltage output from the sensor meets the expected level. Terminal number 2 typically corresponds to the VCC3 signal, which should indicate approximately 5 volts under proper operational conditions. If this voltage is measured accurately, it confirms that the power supply to the sensor is functioning correctly, aiding in diagnosing the overall condition of the throttle position circuit. Conversely, if the voltage levels do not meet expectations, this may signify fault conditions in the sensor or its associated circuit. Correct diagnosis of this step is essential for identifying whether the TP sensor itself requires replacement or if the issue lies elsewhere in the system. After completing all necessary repairs and replacements, final repair verification is essential to confirm that the DTC P0122 issue has been resolved. This typically involves a test drive under various operating conditions to validate that the vehicle exhibits normal performance metrics. During the test drive, you should check for any reoccurrence of DTCs using the HDS, ensuring the system no longer registers error codes indicative of throttle position sensor issues. It's equally essential to ensure the throttle position sensor functions properly, guiding the ECM in optimal air-fuel mixture regulation. Conducting this verification step solidifies the repair and provides assurance that the vehicle is performing as intended, thereby enhancing confidence in your work. Preventive maintenance is a vital aspect of vehicle upkeep, especially related to sensors such as the throttle position sensor. It is advisable to regularly inspect the throttle sensor and its connectors to identify any potential wear or damage before they escalate into more significant issues. Routine inspections can help detect corrosion, dirt, or loose terminals that could compromise sensor function and lead to DTCs such as P0122. Equally important is checking the integrity of the wiring that connects the sensor to the ECM, ensuring that it's free from fraying or breaks. Establishing a maintenance schedule for these components can prevent future complications and extend the lifespan of these critical engine management systems, thereby promoting better performance and reliability. In conclusion, understanding the function and importance of the throttle position sensor A is pivotal when dealing with DTC P0122. Recognizing how this sensor affects engine performance highlights the necessity for thorough diagnostics when issues arise. Following the structured troubleshooting steps we discussed ensures a systematic approach to isolate and remedy the problem efficiently. Moreover, the final verification and preventive measures are essential to guarantee that repairs are both effective and long-lasting. This comprehensive understanding of the DTC and proactive maintenance will help maintain the vehicle's optimal performance and minimize future issues related to the throttle position control. By adhering to these best practices, mechanics and vehicle owners alike can maintain their Hondas in peak operational condition. Please like and subscribe to the channel. See you next time.